Hello and welcome to the Global Passive House Showcase, presented by Passive House Accelerator, a catalyst of zero carbon building. We're happy you're here. We welcome all comers to our exploration of how to slash the greenhouse gas emissions from our buildings and make them more resilient to the extreme temperatures, the wild weather, and the grid insecurity caused by climate change. So, whether you're Passive House curious or Passive House expert, this is a place to learn the do's and don'ts, the best practices, and the lessons learned of Passive House design and construction. We'll dive into how Passive House design principles are applied in the real world and how this approach to construction impacts the health and happiness of the people who live and work in these buildings. Are you new to all of this? Visit the Passive House 101 section of our website to get started. With that, please enjoy the showcase and pose your questions in chat for the discussion session after the presentation. Thank you. All right, so we are very excited to have this special showcase. Oops, I don't think I'm sharing the right screen. Let me try that again. There we go. The Global Passive House Showcase today will feature a living building with passive design. So we have Kathy Berg of ZGF Architects, Marc Brune of PAE Engineers joining us to present about this fine project, and Mike Steffen of Walsh Construction here as guest host. So before we dive into the meat of the program, though, we are going to go into some breakout rooms for about 5 minutes of socializing. So let me set those rooms up, and this is going to be quick. So please do some rapid fire introductions to one another, and we'll go from there. Let's see. Okay, so I'll see you in a few minutes. Thank you. Welcome back, everybody. I hope that was fun. And we're super excited to get on with the program. And my son is doing a Japanese tutoring session right now. So if you hear any background noise, that's what that is. And my apologies. So I have the honor of introducing our guest host today. And our guest host is Mike Steffen. Mike is the Director of Innovation at Walsh Construction, and he's also a pioneer in passive house and high performance construction in the Northwest. And probably most of you are familiar with his work. He's an architect and constructor who is passionate about making better buildings that contribute to a more sustainable and equitable world. He obtained degrees in architecture from the University of Kansas and the University of California, Berkeley, and is licensed to practice architecture in Oregon and California. He's a dear friend and an inspiring practitioner, and we're really happy to have him join us tonight as guest host. So Mike, please take it away and kick us off. Aha, there you are, Mike.
Unmuted, okay. Yeah, for myself and Walsh, it's been a real privilege and also a challenge, I will underscore, to be involved with such a remarkable project as the PAE Living Building, and with such a great team as Marc, who we have here tonight, and Paul Schwerer, and the entire team at PAE, and Kathy and her team at ZGF. And also importantly, I'd like to mention Jill Sherman and the folks at Edeland and Company in Portland, who were the developers, and were so critical to mission success on the project, and so many others, from design team members to subs that were involved. Right now, all I can say is, wow, we've pulled it off. We've turned over the building a few weeks ago, and we had talked about construction. Actually, I don't know if that was getting the cart before the horse, but we talked about construction last night on the Accelerator Happy Hour, and tonight you will all hear more about the design, and I'm sure you're looking forward to that. Zach and I discussed in the lead up to this, what I think is the key relevance here of a project like this to the passive house community is, as a fellow traveler in that path we are traveling, as many of us in the industry, to get to where we need to be for our future and the future of our children and future generations, a low carbon future that we envision, and one that's having as little environmental impact as possible. Obviously, passive house has a massive focus on the energy side of that equation, but there's other elements to environmental impact, which is where I think Living Building really comes and shines in its leadership in taking that to another level than what we see normally. And the rigor that we see in passive house is also something we see underlaying the Living Building standard, particularly the requirement that not only do you model the building, but you've got to prove that performance in the life of the building. So, so it was really exciting for us, for myself personally, for Walsh as a company, to be able to partner with these leaders in sustainable design and put this project. And so now I'll just introduce Kathy Berg and Marc Brune. Kathy is a partner at ZGF Architects, a leading architectural design firm that works across not just the country, but across the world. They're based here in Portland with many offices in other cities. Kathy has led the design of some of the highest performance buildings in our country, and she is passionate about this work, which will become clear when you all hear her talk in just a moment. And Marc is a principal at PAE Engineers, the folks who had the vision for this project, the incredible vision, which I'm sure we'll hear about. And he has led the mechanical and energy systems design of numerous, not just high performance, but net positive energy buildings. Again, not just in the Northwest, but across the country. They're both leaders that are helping show the way as our industry moves towards that low carbon future we're looking for. And I am really looking forward to what they have to share with us tonight. So take it away, guys.
All right, does everyone see my screen, PAE Living Building?
Looks great.
All right, well, I'll jump in since I think we got about 20 minutes for our show here to kind of get you introduced to the building and some of it, and then some question and answers. So yeah, thanks for joining us today for the talk about the PAE Living Building. I'm Marc Brune, and yeah, really looking forward to moving into this building next week. Just really briefly about PAE, we're an MEP consulting firm headquartered in Portland. So this is going to be our new corporate headquarters. We have about 200 people in Portland, 350-ish overall, and 4 offices, up and down the West Coast, basically.
So a little bit about ZGF. As Mike mentioned, we have 6 offices, 1 in Vancouver, BC, the rest stateside, Seattle, Portland, LA, DC, New York. And we really cover a lot of different project types. But one of the the fundamental drivers for us as an organization is maximizing human performance, looking for projects with deep sustainability goals, focusing on equity in architecture, and the integration of technology. And one of the reasons we were really excited about this project is that when Paul and Marc called and said, hey, do you want to work on this with us? It hit every one of those targets. So the living building that we're building is 58,000 square feet. We are seeking full ILFI 3.1 certification, so all of the pedals. One of the things that we're really proud of in this building is that we started kicking the tires on it, talking about how long it was really designed for. And we really believe that with proper care and maintenance, that this is a 500-year building, one that, we hope PAE is in for a long time to come, or someone else who loves it just as much. And the final driver as we were working through the design, not just focusing on LBC, but also making sure we were developing a project that was something a developer could invest in. We don't want these buildings just to be something for a foundation or a private entity who can afford to put a little extra money in. We wanted to make this appealing to everyone and get more of these out on the street. And that drove every decision as we went through the project. The design team had experience in this realm. So PAE, you probably are familiar with, had worked on the Bullitt Center in Seattle and were living in it. So they truly understood the value of such a building. But most of the design team members had also worked on a living building for the Rocky Mountain Institute in Colorado. This is a PETAL certified building that is operating energy positive. And it was one of the largest FIAS certified offices in the US and the first ever to receive FIAS 2015 certification and Source Zero certification. So we'd gotten into this, we'd started digging into this. This also had mass timber structure inside of it. So there were a lot of lessons learned that we were able to carry forward from the Bullitt Center, from the Rocky Mountain Institute into this project. And I think moving to the team, that's one of the most important things about this project, was putting together a team who, first of all, everybody at the table was passionate about doing a living building and making this happen. Nobody at the table was willing to ever say no. So with PAE really driving this not only as the owner, but also as an investor and as the engineer was critical. ZGF, Edelin and Company were also investors in the project, as well as bringing our expertise for architecture and development. KPFF was our engineer from Rocky Mountain Institute, and so again, had lots to bring forward. And then we brought on Brightworks, Biohabitats, and Walsh Construction for, the heavy lifting of building it. So it was just a phenomenal team all the way through. This is our site. So this is in a historic district in Portland, Oregon, about 3 blocks off the Willamette Riverfront. This is the building that was originally on our site. It was called the Reed Block. And this was about 20s or 30s. At some point, this particular building was torn down. We're not exactly sure when, but somewhere in the 40s or so. And since then, it's been a parking lot. So a really underutilized location for the last 70 years. And we started construction on this site in April of 2020, just in time to hit COVID, ice storms, wildfires, clashes in Portland, you name it. We have lived through just about every unrest. It has been a construction phase of biblical proportions, if you will, but somehow we've made it through. So as Mike mentioned, PAE is currently moving in, and we're really enjoying kind of seeing how they're settling into the space, even as we're still buttoning up the last elements.
So yeah, from a living building perspective, one of the requirements of a living building challenge building is net positive energy. We have to produce 105% at least of the energy that we will consume on site with new renewables that ideally are on the building. We'll talk a little bit about how we're looking at that, because we're taking a little bit different take on it. We have a super efficient building with an EUI of about 19 or so is what we're modeling. And like Mike said, for the Living Building Challenge, you actually have to prove it. So it's after a year of operation that you can get certification. So, we're modeled at 19.5 EUI. This section illustrates the mechanical systems we have. One of the differences we have from a lot of other living buildings is we didn't go with ground coupled heat pumps. We went with air source, and that was really a developer-led, financial requirement. It saved us $300,000 or $400,000 of wells, had a minimal impact in our climate, actually, on the anticipated energy use of the building. And we just tried to really manage the refrigerant piping so that it was tightly contained and could be really well sealed, so that we could make sure that we didn't have leakage issues, because it was something we were concerned about as we moved to that. But the building has Automated operable windows that will open and close based on indoor and outdoor conditions is kind of our first level of cooling in the building, first level of ventilation. When conditions aren't right, we have radiant floors. It's a changeover radiant floor system. It's an air to refrigerant system from those rooftop condensers. So again, it was a strategy to not bring refrigerant throughout the entire building. We kind of bring refrigerant from the roof down to our ground floor level, and then we distribute water from there. So heating and cooling out of the floors. I fought pretty hard to keep carpet out of there so that we could maintain our capacity in the floors, and I won almost all of those battles. Let's see what else we have. We have over here, there's floor by floor air-to-air heat exchangers. So it's at each floor that the air-to-air heat exchange happens, and then we exhaust all of that out through the roof. Getting to the roof, there were a lot of demands on the roof. We have 133 kW of solar on the roof. There were a lot of restrictions on the solar. Other, 5-story living buildings that have 105% energy generation requirements typically have big overhangs. Bullitt Center has 15, 20-foot overhangs on some sides. The Rocky Mountain Institute didn't, but it was a 2-story building, and we had just a ton of solar generation for the square footage. So we were limited. We couldn't do overhangs because of the historic district we were in. Just design requirements wouldn't allow any PV to be seen from down on the ground, which meant we couldn't elevate it up, which meant that now we needed walk aisles for the fire department around there. It's kind of in yellow as all our walk aisles. We also had a utility restriction on the PV. We're in a downtown area network where sort of the traditional is maybe not the right word, but the conventional wisdom is you cannot backfeed at all into a network grid. We actually negotiated with the utility to allow a limited backfeed. We have 50 kW that they're letting us feed back into the grid. And then we have a microgrid system that is controlling that. So we have a battery. It's a 250 kilowatt-hour battery. It's worth about, if you think of the energy in 3 Tesla vehicles, it's about that much energy. And so we can soak up all the power on the weekend when we don't have the load for our PV, and then kind of meter it out slowly throughout the day. The roof surface is also our rainwater collection. We have a net positive water requirement that I'll talk about. So just a ton of demands on the roof and a lot of PV up there. The PV is actually in a sawtooth pattern. It's facing east and west, which is a way to maximize our area of PV that we could get on there. It actually maximizes the generation we got on the roof rather than everything facing south. And this is a little less than half of the PV that we need for our net positive energy. We would have needed about 350 kW or so of PV to get to net positive, but because of those limitations I mentioned, we couldn't get there all on site. And this was something we had to kind of wrap our minds around, is the building owners and the people that showed up with this project say, hey, we want to build this living building, we want it to be net zero energy, and it's like, wow, we can't do it on site. And Walsh actually helped connect us with this project that they were building in North Portland. It's about 5 miles from our site. It's an affordable housing project. And what we ended up doing was making an arrangement with this project. It's a Reach Affordable Housing to donate a 210 kilowatt PV array to Reach. So it powers the Reach building. They actually get their meter spinning backwards. They get the value of all of the kilowatt hours. We get the renewable energy credits. And from a sort of project standpoint, there's additionality on the grid of PV going under this project and ours that's enough to get to our 105% net zero energy operation. We're buying renewable energy for that sort of excess that we need at our site. So from a sort of global renewable energy credits standpoint, there's enough for both of our projects, really. And we're connected to the same utility grid. So from a grid standpoint, the grid really doesn't care whether the PV is on our building or on another building. And I think, I'm really excited about this arrangement now, because all too often I feel like, super sustainable projects have been a bit of a privilege to be able to build, because it is expensive to put a lot of PV on. And with this approach, we're combining the sustainable aspect with a real tangible social benefit at the same time. And I'm hoping, showing a different paradigm for, urban constrained buildings, because I do want every building in Portland to be able to get to net zero if they wanted to. And this is one way you could do that. The other side, and I'll try and kind of move quick through this, is the net positive water. So we harvest all the water from the roof of the building. It flows to a 71,000 gallon cistern that is the only thing that's below our building other than the ground. We treat it kind of like you would when you go camping. We got just a super fine filter that we run it through. We add some UV to it after that filtration. Then we have to add a little bit of chlorine that flows to all the fixtures, the labs, the showers, where people will use the water. From there, it runs down into our gray water storage tank. So we treat it then again with a fabric filter, and then send it back to our water closets and the hybrid urinals that we have. The urinals flush about once a day just to kind of keep the traps clean. The water closets are vacuum flush, which is pretty unique system to just about any building, but it's a 5-story vacuum flush system. A little bit has kind of a similar experience to being on an airplane. Uses 1/10 of a gallon per flush. It sends it all down actually to a sump, and then it gets distributed to the 20 composters that we have in our building. There's 20 big 7-foot tall composting bins, and it distributes it evenly between all the bins, which was a lesson learned from other living buildings that we've worked on. There's also there's a backup option. There's kind of a 21st place that it could go, and that's to the city sewer. We wouldn't normally do that, but it's a backup if we ever run into problems with the composting system. So we kind of, close the loop, I guess, in the end on the, on the nutrient cycle of, collecting water on the roof, and then hopefully really, generating compost that can rebuild soils rather than just sending it to the municipal treatment plant and dumping it, a lot of those nutrients back into the river.
So looking at the design, one of the things that we really prioritized was thinking about the location in the historic district, and also thinking about how that historic district would coincide with all of the energy and performance goals that we had. One of the proportional guides used throughout the historic district is the golden ratio, which is a proportion found in nature everywhere from galaxies to seashells. And we tracked that ratio back through a lot of the historic buildings and proportions, and looked at how we could carry that forward to our building. So when you look at the district, one of the things that you'll notice about many of the buildings, they all have this proportion of larger ground floor buildings, or larger ground floors, proportional center floors, and then a lot of detail at the top. Most are also built the full block dimension. They come right up to the street edge. And those were things that actually worked well for us, as well as we were trying to maximize the footprint that we could fit inside, but also the proportions of these windows and openings, how they would work with our energy systems. Another benefit of the site was the height. So as Marc mentioned earlier, a 2 to 5 story building can really work within the water and energy resources that it can receive, and serve the power and water needs inside. As you go beyond that, the site becomes very difficult to gather the resources that you need. So this 5-story worked pretty well once BAE went through and really sharpened their pencil on energy loads and how they could get the internal water and energy reductions in the way that they operated the building. We were able to make the water capture on site work, and Marc talked a little bit about the energy, split the energy between this and the REACH project. The other thing that 75-foot data meant was that we were assured to get the solar access long-term. There won't be a building built nearby that is taller, and therefore we know we won't get blocked, which was very helpful. as we look at those historic buildings, they had to meet the same requirements that we do today. So even though they were 100 years apart in development, they were also focusing on daylighting, natural ventilation, and passive cooling because they didn't have the mechanical means or the artificial means to create that when they were built. So the fact that they were dealing with the same concepts as we were dealing with today meant the look and feel of our building really aligned with the district. So looking at our exterior envelope, you will see a lot of the same characteristics that you see in the district. At the ground floor, you see a greater level of detail. You see our entries are set back. You see these strong verticals and horizontals that articulate a very repetitive frame, which is characteristic of the Italianate cast iron district that it is part of. The ground facade is really dominated by windows. There's clear delineation of the floor lines. And then at the upper level, you see recessed operable windows and a real detail at the cap, at the parapet. In terms of materiality, one of the requirements that the Living Building Challenge has that is much stricter than most other labels or certification systems is to select materials that meet that are red list free. So do not contain some 23, 26 chemicals of concern. This actually, again, aligned really well with a historic district because many of the materials that we've used historically are of the earth. So the masonry was a very easy material to select as it was pretty easy to find red list free. We also have insulated glazing units, aluminum storefront at the ground level, fiberglass windows from Cascadia at the upper levels, and aluminum panels infilling around some of the windows. That was probably one of the harder materials to source, to be honest, red list free. The painting is still an area that it's easy to get the paint. It's not always easy to get the primers. So this is one of our one of the things that we're learning in terms of the wall assembly. For those of you, we've got a couple of images here for those who want to geek out in the detail bits. From our window assemblies are actually pretty complex and took a lot of back and forth between the engineering team and the architecture team. The top awning window that you can see in the bay that shows is operable and swings out is actually on an actuator and tied to the MEP system to support night flush. The casement window, the larger casement window that you see is accessible to the desks and the occupants inside so that they have the ability to control their internal environment and have that direct connection to nature. I can tell you that the glazing area is just barely under 30%. That is not the total window frame. That is literally just the face of glass. And the reason I know that is because Portland has implemented a bird safe requirement. And the glazing on this would have needed to have been covered with some sort of dot pattern or film if we would have exceeded that 30%, because there's a lot of statistics that show a lot of bird strikes in that area. Since that wasn't really in keeping with the historic district, we chose to be just under that limit, and it really became another one of those performance tools. We were constantly measuring back and forth to make sure that we had the daylight, but we still had the energy performance. The next slide will show a detail of how those assemblies come together. So here you can really start seeing the brick detail that we played with. There's a lot of it. We worked directly with the masons to try to optimize what we could do, how far we could move those bricks, how much shadow and texture that we could get. So we really got that feeling of a modern building that had the detail that you would see in a historic district. To get our envelope insulation, we combined both rock wool and bat insulation that you can see here. We also selected things like stainless steel flashings, first because it helped us achieve the red list, but also because the stainless steel would get us towards that 500-year building. So between the brick veneer, the stainless steel, the mass timber construction I'll talk about in a second, really looking at systems that could last for a very long time and have proven in other cultures around the world to last for 500 years. Structure was a really interesting one, and this was a great opportunity. We knew we wanted to embrace mass timber. It's a Pacific Northwest sourced material. It's beautiful. We knew we could use the structure exposed, so it removed a lot of other cover-up materials that we had to use. But we also knew we had to be cost effective with it. So we did combine it with concrete core walls and a 3-inch topping slab that runs the radiant heating and cooling that Marc referenced. And worked really carefully with that mass timber to create mechanical chases that we could organize running conduit and fire suppression and things within. As we were studying the mass timber system, we realized that because we were on a tight urban site located next to other buildings, that if we had designed in our earthquake prone zone to a category 3, which was required by code, we would need an 8-inch separation between the two adjacent property lines. But if we went ahead and spent the other extra money to make the building more rigid, which wasn't overly expensive because a timber building is fairly light, and so it's easy to make it fairly rigid, we could actually reduce that gap to 4 inches. And the trade-off was that increased the amount of space that could be rented. And so from the pro forma standpoint, the developer was able to say that the increase in structural cost would pay for itself in a very short period of time. So that's another reason we feel this is a 500-year building, is that structural upgrade means that in an event, the building structural system will remain operational with little to no damage that needs to be addressed. And this is what that looks like inside. So it really does bring a beauty and a warmth and a character to the space. And so really all of our materials have been left exposed to the extent that we can: the concrete floors, the concrete shear walls, and the wood columns, beams, and floors. So that's that 4-inch spacing that we were talking about as a real benefit.
Sorry, Kathy, I was jumping around there.
Okay.
We got that. Yeah, so I can jump in on this here just a little bit. The one of the other things we looked at was the embodied emissions of the building, and you know, we're around 2,500 metric tons of CO2 in our building. Because we are a you know, an FSC certified, sustainably harvested mass timber building, there was a real reduction in the embodied emissions of the materials we put in the building. It was about 25% or so. Early on in the schematic design phase, we had put together a bill of materials. Walsh helped us do this, of concrete and steel and wood. We're really still trying to decide, what do we want? We all wanted the wood building for the look of it and, you know, the natural materials, but we needed to make sure we could price it out and that it made sense, and we were able to get there. But it gave us an opportunity then to take that bill of materials and say, well, what would the carbon impact have been of the others? And that was how we backed out sort of the 25% benefit of our wood structure. The interesting thing to me is, you know, in that donut chart to the left, that's the breakdown of our wood building and sort of where all the carbon is embodied in our structure. And there's still about 1/3 of it in concrete. So just to me, you know, looking forward to the next living building that I hope to get to do soon, you know, concrete is by far the low-hanging fruit still. You know, can we do concrete or wood rocking shear walls potentially? Can we get an all wood diaphragm and eliminate the concrete from the deck of the building? Yeah, I think there's a lot of things we can still do to get that out, because when we look at the emissions of the building over time, you know, we see that we start with a really significant deficit. You know, this chart has on the horizontal axis years, and it's interesting to look at it. You know, it's 3,500 tons for that base building, maybe 25 for ours. And if you chart that out, you know, we're 20, 25 years into operations of our building until we hit that level of emissions again. So it's, you know, I think it's really critical for all of us as designers to look for ways to, you know, to pull down the embodied carbon in our buildings, you know, ideally to zero, which we did with offsets in ours, which is real, but I think, you know, we need to look for materials that make the need for offsets as limited as we can. Yeah, I can speak to this really quick. If you want to add anything, Kathy, go ahead. But we have, you know, at the roof of the building, there's urban agriculture, which is kind of a cool thing that's required as part of the Living Building Challenge. And ZGF designed this amazing space for us that we're calling our deckany. There were so many demands on the roof that we really couldn't, you know, get a roof space where we could have as an open space. And so instead we have nano walls that open wide up. So all those windows that are circled in red open completely to the outside. And I can tell you, I had lunch there yesterday, and the comment that my friend and I were saying was, this is better than sitting on the roof. Where it was, it's amazing to be sort of, you have that feel of shelter, but we had the prospect of sitting by those windows at the same time. So it's a really great space. And then just, putting the financials out there of what this cost us, it was about $435 a square foot total to build the building. The energy and the water systems alone are about $50 a square foot, about 25 each for the water and the PV. But in the end, as a developer-led model, that the upfront cost is really not what matters. It's what the return is, and we've got about a 10% return for our investors is the goal. We're paying a slight premium over sort of a Class A market rent when we move into the building, but if we get a 1% improvement on our employee productivity or a 1 or 2% reduction in turnover, it completely pays for it. And studies are anywhere from 1 to 10% improvement in productivity. So I have high confidence that we'll be actually to the good in moving into this. So just to recap it, we've got net zero energy, net zero water, red list free materials. We have a contribution to an affordable housing project. We have a 500-year building that's built to Category 4 seismic. And we did it all in a way that I think is, I hope, other developers are paying attention to, because we think it's financially replicable. So I think with that, we can open it up for some questions.
Wow, Marc and Kathy, that was amazing. So before we dive into the questions, first, if everybody would like to unmute and give this amazing presenters a huge thank you and congratulations, please.
Thank you. Well done.
Cheers.
Again, another project where the bar is now set up here for everybody else. So hold on, Marc and Kathy, you have a sip of whatever beverage you're having. And Zach, over to you.
Yeah, thank you. Let's see here. Rockwool North America, Still Corp, Zola Windows. And our champion sponsors are Icon Windows and SIGA. Our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, Aero Barrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood T-Stud. So thank you to our sponsors, and thanks for your patience, everybody.
Thanks, Zach. Everyone who doesn't know me, I'm Sean. I'll be the question concierge, and you can see from the list, we have a lot. So Marc and Kathy, I hope that you're going to be able to hang out with us into the after hour, because we've got some good ones here. And as Dale said, yeah, last night on the construction tech, we went to the distance. So let's get into it. Hold your questions. Again, I for those that had multiple questions, I put you back in the queue. But Cameron, I'm going to bump William and Shelby first, because the whole story of the 500-year plan is cool. I think Mike will have to answer it, but William and Shelby, go ahead and ask your question.
Hi, that was a really great presentation. A lot of beautiful graphics and an awesome building. As Marc, we had mentioned on our 5-minute breakout room session there, my wife and I are trying to design our own personal home to Living Building Challenge standards, and we're really excited about your building and have really a ton of questions, but we'll stick to the 2 that we have here right now. So the first question was really the 500-year useful lifespan that you guys came up with. Is that based off of any type of specific calculations? Is it more of a rough estimate? Do you have any math behind that, or how did you develop that number?
Well, I'll start. I'll say, as a little bit of more of a philosophical discussion, I guess we had about, what what does it take to make a 500-year building, and what does that look like? And and I think the structure was a big thing that we came upon, is like, we need to have a structure that can last. And I will say, I don't know if you can see it in the background here. There's a building there that's the building that my mom grew up in, and it's a 350-year-old building in Germany. So it's starting to get there to that 500-year lifespan, built with nowhere near the technology that we have. But and I kind of kept coming back and thinking to that. It's like, we were doing it in the 1700s and building buildings that last like that because, they were built to, they were built in a way that people loved them, and they maintained them. And so I think, if we can manage the seismic side and our side here and build a building that people are passionate about and become sort of part of the landscape, I feel like it's not unrealistic to say that.
Yeah, I would add, this was, I think, Paul Schwer, kind of tossed this question out to Walsh and to ZGF and everybody and said, all right, how would you evaluate this? Because we're often asked to design a 50 to 100-year building for a university, right? And the first thing that we do is we start to pick materials that we know, is that brick going to be around in 100 years? Yeah, that brick's going to be there. Is the backup system, the structural system you're leaning on, going to be there in 100 years? Well, there's lots of proof that a mass timber structure, if you start to look at some of the timber construction in Japan, been there for a really long time, even in high seismic zones. So we felt that was there. And we acknowledged that, yeah, there's maintenance. Sealants are going to have to be replaced. Potentially window units may have to be replaced at one point in time, but certainly will re-roof. Panels will be replaced as they become more efficient. But as we went through it, we tried to analyze, was there ever a point where the building, if it was being maintained, would it ever break to the point that it just didn't work? And given that I think we focused on daylight and passive strategies, and there is the ability to enhance if climate change gets a lot worse, great. But also I think the PA team did a good job of looking at climate data that was really forward looking to make sure we are insulating ourselves from change over time. So it wasn't math per se, but I think it was a lot of engineers, architects, and contractors looking at it and saying, can we be confident that this is still going to be here in 500 years? And we all felt like the answer was yes.
That's awesome. Yeah. And I love the fact you're bringing about history, looking at the past and building our future based on some of that. I think that's really cool.
Yeah, definitely. And I know that beauty is part of the Living Building Challenge as well. And it makes a lot of sense. When you build a beautiful building, not only will you want it to stay there for a long time, but everybody else will too. Yeah. So cool.
We sure hope so. It's good to hear comments like Marc's, that people appreciate what's there, because you put your best foot forward, but somebody else gets to live in it when you're doing commercial architecture. So yeah.
Absolutely.
Hey, just because William and Shelby, we're getting close to the top there, why don't you ask the second question? And because I know Mike will probably comment about the 500-year discussion too before we wrap up. So go ahead and ask your second one.
Cool. All right. So my question was about the composting toilets and whether or not code, like local state code, if they let you actually use that, like, do you have to send it, even though now it's fertilizer and perfectly usable, do they have a mandate that you have to send it to a wastewater treatment facility? Or is there a plan that like you partner with local farmers? Or I just want to know what you do with your now usable poop.
Yeah. So we don't have a connection yet for where it's going to go. We're sort of working on where that's going to go, but we will not need to send it necessarily to the wastewater treatment plant. It'll probably come off as a Class B compost, which means it can get applied to non-food crops. If occupancy were low enough, maybe for the first year due to COVID, still we might even get Class A off of it, and then it could go to food crops. So yeah, it's not something that is on the radar really of a lot of codes, So surprisingly, that one was one of the easier ones to permit.
Good to know.
That's cool.
Excellent. Great questions. All right, we're going to go over to Zach, and then we'll go to Mike.
Okay, great. So why don't we actually, Yes, you're right. That's right. That's what I need to do. Boy, I'm a mess today. Okay, here
Oh,
we
it's
go.
okay. I'm melting into the passive house matrix of today, so it's okay. Go ahead, Zach.
However, I actually think I'm sharing the right image, which is an image of Maria Callao from Sir Architecture. She is the guest on the Passive House podcast episode this week. An interview with Matthew Cutler Welsh. Maria practices in New Zealand. She talks about her research around fuel poverty in New Zealand, as well as her experience living in a passive house co-housing development and her own architectural practice. So check that out. Then next week on Passive House Accelerator's Construction Tech on Tuesday, we have James Hartford from River Architects talking about supplies and labor shortages and how to build passive house during those shortages. And the role that alternative building systems can play. So join us on Tuesday for that. And then then my last announcement is about the Global Passive House Showcase next Wednesday. This is an amazing project in New York. It's a recladding of a 20-story apartment building. This is all within the context of Local Law 97 that is compelling building owners to improve their buildings to lower emissions. And this is a really inspiring example of how to do that. So Alyssa Boucher will be presenting, and Andreas Benzing from New York Passive House will be our guest host. So join us next Wednesday. Thanks, everybody.